Alright, here are the video notes for lesson 1.2, focusing on the graphs of equations. We're going to sketch graphs. We're going to find X and Y intercepts. We are going to talk about symmetry, symmetry about the origin, symmetry about the x-axis, and symmetry about the y-axis. And then the last thing we're going to do is talk about circles. We're going to have an equation for circles and how we can plug in the center of a circle or find the radius. But let's get started. So the first one is just determining if a certain point lies on a graph or not. And what we're going to do for this is we're going to plug in our y and our x into our equation and see if they equal each other. So 13 is our y, then we have 10 times our x, which is 2, minus 7. That's going to be 13. 10 times 2 is 20, minus 7. So 13, 20 minus 7 is 13. Since 13 and 13 equal each other, that's a yes. That point lies, that point 2-13, 2 comma 13 lies on the graph. Again, all we did was plug in our y and our x and see if they equal each other. And so the next one, negative 3, we plug in for y. 10 times negative 1 minus 7. Negative 3 equals negative 10 minus 7. Negative 10 minus 7 is negative 17. And so negative 3 does not equal negative 17, so that is a no. That point does not lie on the graph because we did not get something equal to our y. Alright, moving on to sketching the graph. Remember, I want to see this as y equals mx plus or minus b. And so just to move this around to help me, to help you, I want to change this to y equals negative 3x plus 7, because that's a positive 7. And that just helps me see that the slope is negative 3 over 1, and your y-intercept is a positive 7. So what I do, my y-intercept is positive 7, so I go up to 7. That's where I'm going to start. And then I go down 3, because that's my rise over my run, down 3 over 1, 1, 2, 3, there's my next one, 1, 2, 3, there's, 1, 2, 3, there's my other one. You could also go up and to the left, 1, 2, 3, 1, and you have your line built, at least with the points we have. And so we draw it through, and it'll look something like this. Alright, and that's just your basic linear function line graph. And it's not too bad because all we need to know is the slope and the y-intercept, and we can build the line. Next one's a little bit different. We have parabolas, and so we'll learn more about parabolas and how we can shift them. But where we are now, I'm still just going to use an X and Y table. And so if I go down here, X, Y, and I'm choosing my X's here, negative 2, negative 1, 0, 1, and 2. And I'm choosing them so that I have some part negative, some part positive, so I can get a full picture of my graph. We'll talk more about sometimes that picture moves, but that's going to be later on. So right now I'm just going to plug in my X's, see what I get for Y's. Negative 2 squared is 4. 4 minus 2 is 2. So that's 2. Negative 1 squared is 1. Minus 2 is negative 1. 0 squared is 0. Minus 2 is negative 2. There's always symmetry with parabolas, so the second half here is going to be the same as the first, meaning it's negative 1, negative 2. And if I wanted to plug in to check, positive 2 squared is 4. 4 minus... sorry, that's got to be a positive 2. I caught my error by talking about it. Because 2 squared is 4, 4 minus 2 is positive 2. And then I can plot points and graph. So negative 2 up to 2, negative 1, 0, negative 2, and then the symmetry on the other side. My graph looks something like this, and I can draw the parabola portion of it. Okay, not perfect. Writing on my computer makes it hard, but that's what we're working with here. Okay. Same thing goes for over here. I'm going to use an XY table, but I'm going to move things around a little bit so that this is y equals negative x squared. I like doing that so I can remember the negative is outside, plus 5. And I'm still going to do an XY table. Using the same x, negative 1, or negative 2, negative 1, 0, 1, and 2. And plugging in, I get negative 2 squared. Negative 2 squared is 4. 4 times the negative is negative 4. Negative 4 plus 5 is a positive 1. Negative 1 squared Negative 1 squared is 1. The negative makes it negative 1. Negative 1 plus 5 is a positive 4. 0 squared is 0. The negative doesn't matter. 0 plus 5 is 5. Symmetry tells me that it's going to be the same on the other side. And so I can plot those points. Negative 2, 1. Negative 1, 4. 0, 5. And then the symmetry. And my parabola this time is going downward. And what's happening there, why those two are flipped, because right here we have a positive x squared. Here we have a negative x squared. That negative x squared is going to flip it. That'll be again talked about in future lessons when we talk about how we can transform graphs. Let's get into intercepts. It's a good place to pause and take notes here because I'll move by it pretty quickly. But really what it's saying is x-intercepts where it crosses the x-axis, y is where it crosses the y. And so I just want to draw it out. Like if you have like a line, that's your x-intercept. That's where it's crossing the x-axis. Your y-intercept, if we had a graph, it's right here. That's where it's crossing the y-axis. So again, you could pause and take notes on that. Make sure that's written down. Finding the x and y intercepts. So like it will say in your notes, if you want to find the x-intercept, plug in 0 for y. If you want to find the y-intercept, plug in 0 for x. And so that's what we're going to do. We're going to plug in 0 for x and 0 for y. So the first one we're going to do is find the x-intercept. So 0 equals x cubed minus 4x, which is going to, we can take x out, and we're going to get x squared minus 4. And then that actually can be broken down really nicely. And we're going to end up with 0 equals x minus 2, x plus 2. And so we actually have 3 x-intercepts here. We have x equals 0 from this guy right there. We have x equals a positive 2. And we have x equaling a negative 2. And those are all our x-intercepts. It's okay to have multiple. Y-intercept, we need to plug in 0 for x, and so this is y equals 0 cubed minus 4 times 0. And so it looks like our y-intercept here is just going to be y equals 0. And that's going to be our x, all these x's, and our y-intercepts there. Clear my ink here and move on to part B, same kind of thing. We are going to do the y-intercept first, so we're going to plug in 0 for x. And so we're going to get y equals the square root of 2 times 0 minus 1. 2 times 0 is 0 minus 1, so that's the square root of negative 1, which we cannot take the square root of a negative. And so there is no solution for this first part, which means we do not have a y-intercept. Again, because when we try to do it, we ended up getting that square root of negative 1, which we cannot do. So now let's try to find our x-intercept and plug in 0 for y. So we get 0 equals the square root of 2x minus 1. To get rid of the square root, we got to square both sides. So that's squared, that's squared. You get 0 equals 2x minus 1. Add over the 1, that is 1 equals 2x. And you end up getting 1/2 equals x as your one and only x-intercept there. So again, if you want your x-intercept, plug in 0 for y. If you want your y-intercept, plug in 0 for x. C we could do, but it's the same thing. I'm going to skip it. Alright, symmetry. So symmetry is kind of, I talked about it a little bit. If we look at these graphs, that has x-axis symmetry because what's happening on the left of the x is the same thing that's happening on the right. So that's a good example there for symmetry is x-axis symmetry looks something like this, where your x and your y here, so if you have negative x, I'll write it out like this. Second. Geez, I screwed that up, so forget about this right now. That is, I'm talking about y-axis symmetry. That's in my head right now. This is the y-axis here. that's the y-axis, so this has symmetry about the y-axis, and so does this one. Sorry, my apologies. It took me a second. But x-axis symmetry will look something like this. So it's that kind of parabola shape, so that what's happening above is the same thing that's happening below. And if we choose a point like here, that point would be x comma y, and that means this point down here should give you, if you plugged in a negative y, you should get the same x. And so you should see that relationship with x-axis symmetry. Y-axis symmetry, that's what I showed you in that one graph. That's with the parabola here. And that is, so like if I choose a point right here, that again is x comma y. And if I plug in the negative version of that, the negative x version, I should get the same y. So that's negative x comma y. And then origin symmetry looks something like this, where I could go up here and then down here. And that would be my xy point because it's positive x, positive y. And you should get the same kind of equation if I were to plug in negative x and negative y. And you'll see what I mean when I actually do examples of this, but that's how I'm going to describe symmetry when I need to define it. So for symmetry with respect to the x-axis, if you plug in x, positive x, and negative y, you should get out a positive x and a positive y, because that's what we're talking about with that symmetry again. If I have an equation and I put in a negative y and a positive x, I should come out with the same answer as positive x and positive y. Here, if I put in, with respect to the y-axis, if I put in a negative x and a positive y, it should come out positive x and positive y. And lastly, for the origin, if I plug in a negative x and I plug in a negative y, it should come out as a positive x and a positive y. And we'll see that with some examples coming up here. So the first one is just testing for symmetry with both axes and the origin. So like I said, we're going to start with the x-axis, so x-axis symmetry. And we're going to plug in a negative y and a positive x and see if we get positive x and positive y. So plugging in, that's negative y equals 2 positive x cubed. Working it out, that's negative y equals 2x cubed. Divide negative 1 on both sides, that's y equals negative 2x to the third. Since this equation right here is not the same as the original, it doesn't have symmetry. No x-axis symmetry. Now if I plug in, let's try the other one, y-axis. Let's plug in a negative x now, because if I plug in negative x and a positive y, I should get out both positives. And so I plug in, that's y equals 2, plugging in my negative x cubed. Y, negative x cubed, so x squared is positive x. Negative x squared is positive x. Negative x cubed is still negative, so that's negative 2x cubed. Again, since this is different than the original, it does not have the y-axis symmetry. And now let's try the origin. Origin symmetry, you plug in a negative y and you plug in a negative x. Negative y is still negative y. Negative x cubed gives me negative 2x cubed. And if I divide both sides by negative 1, that is y equals a positive 2x cubed. And that is the same. And so yes, it has origin symmetry. All right, it's kind of a confusing concept because we're plugging things in, but that's where the cubing or the squaring or something is going to really help us. And so remember, x-axis symmetry, plug in that negative y, y-axis symmetry, plug in the negative x, and origin symmetry, plug in a negative y and a negative x. I will be able to finish the rest of the notes in a short part 2.